Good morning and afternoon, everyone. Welcome to today's webinar, an overview of MemSQL 6.5, the No Limits database. My name is Jennifer, and I'm going to be your moderator today. Before we begin, there are just a few housekeeping items I'd like to review. This presentation is being recorded, and you are currently in a listen-only mode. You may submit any questions you have at any point via the Q&A chat function in the lower right-hand side of your console. We will address everyone's questions towards the end of today's presentation. After today's presentation, you will receive a follow-up email with a link to the recording and slides. If you wish to contact us, please send us an email to team@memsql.com. So let's begin. Today we will be giving you a quick tour of MemSQL 6.5. As some of you guys may know, our mission here at MemSQL is to create the world's best database. With that in mind, we recently released our latest version of the product, MemSQL 6.5, in which we improved our core performance capabilities while adding new features to simplify and modernize data management. We're excited to show you MemSQL in action today and give you guys the opportunity to participate in a live Q&A with our product team. So with that said, I'd like to introduce today's speakers. Today we have Eric Hansen and Rick Negrin. Eric is a principal product manager at MemSQL, responsible for query processing, extensibility, and geospatial feature areas. He's a PhD graduate of UC Berkeley, was an Air Force officer, a professor of computer science at the University of Florida, and a principal program manager and developer on the SQL Server team at Microsoft. He was named a Hive committer for contributions to Stinger. He's a technology expert on data warehousing, column stores, and vectorized query execution. Welcome, Eric. We also have Rick Negrin. Rick is the Director of Product Management here at MemSQL. Rick has been working in the technology industry for over 20 years and started his career as a software engineer working in a couple startups, followed by 12 years as a product manager at Microsoft on the SQL Server team, working on the core SQL Server engine as well as the Azure SQL database. Welcome, Rick. So thanks for joining us, Eric and Rick. You guys now have the floor.
Thank you, Jen. It's my pleasure today to do the introduction of MemSQL's latest release. It was a result of a lot of hard work from the amazing team we have here at MemSQL. I've been at MemSQL just about 2 years and several releases, and this is by far the highest quality and the most powerful release we've done yet. But before we get to talking about the release, I just want to cover what is MemSQL and what are the industry trends that have been driving it and shaping the product. So the first is something I think that resonates with pretty much everyone I've met and talked about so far, is this idea of being data-driven. That companies want their employees to make decisions based on data because when they do that, they make better decisions and drive the business forward. But to do that, you have to empower all of your employees with data, which means they need to access the analytic systems that they have in the data for the company. And most of those systems were built for a time when there was a handful of analysts in the back room running hard queries a couple of times a day. And when you turn loose your hundreds or even thousands of employees and they'll try to access those systems, they can't handle the load. On top of that, companies also want to empower their partners and their customers with data, either to just enhance the customer experience or even straight up monetize the data directly. It hit the analytic systems by a huge amount. On top of that, it also raises the SLA you need to offer around those analytic systems for availability, reliability, as well as performance. And so you need a system that can handle that kind of load and still scale smoothly, achieving those SLAs that your partners and customers expect. On top of that, people want things faster. It's no longer acceptable to wait a quarter or a week or even a day to get results. You want the results as things are happening. And that means you need to be able to have a system that can allow data to flow in as soon as the data is born and be able to get the data out as quickly as possible, achieving a time to insight or time to action that meets your business needs. And the analytic systems that have been around for the last few decades weren't built to handle that kind of model. They just can't do it. And so these pressures are driving up the requirements and putting pressures on teams like yourselves to get better performance and better scalability orders of magnitude more than what you've been expected to do before. And you want to be able to do it without sacrificing the familiar programming model and tools and skills that your people are already familiar with. And that's what's led us to build MemSQL, the no limits database. No limits in terms of how much you can scale it, how fast you can get the performance, how many users you can push onto it. No limits on the type of application you want to run, whether it's an analytics application or a transactional system, or some combination of the two. No limits on where you want to run the software, whether you want to run it on-prem or in the cloud or in some hybrid model. It's really the database that's built for your use, no matter how you want to use it or what your requirements are. Now, the way we built it was built it up by a series of layers. The first was a highly available distributed storage model, where we shard your data across many nodes in a cluster, keeping multiple copies so we can fail over in the event of a hardware failure. On top of that, we built a distributed SQL processor that supports both transactions, so it gives you asset support, as well as analytics, so you can do complex group bys and aggregates, windowing functions, and the like. And we do this in a way so that it looks from the programmer like it's a single database, where they send in a query, and the system transparently behind the scenes distributes that query across all the nodes where all your data is sharded, runs the query, gathers the results back, and sends it back to the user as if they're just talking to a single database, dramatically simplifying the programming model and the programming semantics for the developer. Now, when you run multiple workloads in a single system, you got to make sure that you prioritize the queries appropriately. And that's why we have the workload manager, allowing you to say, this set of queries is more important than this set, and make sure it gets the resources that it needs in order to meet the SLA for that workload. And we combine that with a distributed ingest mechanism, because getting data in is critical to achieving the time to action and time to insight that you require. So we've made ingest a first-class citizen, a first-class feature in MemSQL. It's built into the product. You run it, start it, and manage it within MemSQL, allowing you to get high throughput using parallel ingest from a variety of data sources. And then on top of all that, it's a multi-cluster management system that makes it easy to deploy, configure, manage, and troubleshoot MemSQL. And what that's allowed us to do, the combination of all of that stack, is to do things like achieve this new benchmark, which is 1 trillion rows scanned per second. We did this running on 12 new Intel servers and leveraging the scale-out architecture and innovative features like our operations on encoded data and query vectorization. This has allowed us to achieve a level of performance unseen by anyone else in the database industry. But you don't have to take our word for it. We have a number of customers leveraging MemSQL to get results like these. And this list is just a subset of the customers we have across the financial industry, large banks and trading institutions, as well as large companies across the media industry, healthcare, and others. So I don't have time to talk to you about all the different use cases, but let me drill into one of them, which is Disney. So Disney had the need to be able to measure how well their streaming media was doing. They want to be able to tell in real time if there's any problems with the quality and reliability of their streaming media, so they could fix it for the users before they even saw the problem. This meant they had to be able to bring in an enormous amount of data very quickly, analyze it, and then act on the results. So fast ingest, fast query, and be able to do that essentially in real time. And they wanted to do it in a way where they could still make the data available with the tools familiar to their users. And so you can see the quote from Adam, where he's saying we needed this low latency real-time system, but to make it available to all of our analysts. And they were able to do that with MemSQL, and they achieved the results they wanted because of its capabilities. So that, I'll turn it over to Eric Hansen, and he's going to tell you all about 6.5, the newest release.
Thank you, Rick. So in MemSQL 6.5, we've advanced performance and added capabilities to accelerate time to insight and simplify operations against data in an SQL database. the focus for our 6.5 release, which just came out in late July, is these three items. The first is enterprise readiness. So you want to make it possible and easy to manage MemSQL inside a large enterprise with large data volumes and lots of users and lots of concurrency. So we're adding ability to manage the system more easily. Second is first-time experience. So when you approach MemSQL for the first time to build a new application, we want that experience to be as easy as possible, and we've continued to add capabilities to MemSQL so that the first time you open it up and use it, start loading data, start querying, things are just easy to do. And finally, a core value for MemSQL is performance, and in the 6.5 release, we've tremendously improved query and also load performance compared to the prior version of MemSQL, which is already incredibly fast. So we're really pushing the envelope for performance. The primary improvements in 6.5 are in these areas. One is just faster query processing, as I said. Another is in the area of automated workload management and also resource governance. They're slightly different, and I'll talk about what those mean. Also, we've got a feature that's been in MemSQL for a couple of years now, which is very popular, known as pipelines, where you can stream data in from multiple sources like file systems, cloud blob storage system, and Kafka, and clean it up, transform it, and insert it into your database. So we've improved our pipeline capability with a new feature called Pipeline Stored Procedures, where you can do in-database transformations as part of these data loading pipelines. And I'll say a few more words about that later. And finally, well, we've got full text search capability and also scalable multi-tenancy. So I'm a query processing guy, and so I just love to see very fast query processing. That there's nothing that makes people just love a database or a reporting application like super fast interactive response time that's very, very consistent. And that's what MemSQL provides. And MemSQL 6.0 was already tremendously fast, but we have just taken it to the next level with 6.5. Our query performance is 2 to 4 times faster for existing workloads. And the main improvement in this area is to do with faster distributed joins. These are up to 4 times faster, and so anybody who's interested can contact us, contact or ask a question at the end. I can tell you how it works. It's a little bit technical, but we've made some very significant performance improvements for distributed joins. Also, we improved performance for what we call high cardinality group by queries, and that just means that a group by query in SQL that has a lot of distinct groups in the output, say tens of thousands to millions of groups, those queries have more than doubled in speed with this new release. Queries that use in-list filters in SQL, we've improved the performance of those in some cases by orders of magnitude. Also, we've improved the query optimizer. As Rick said earlier, we did 1 trillion rows per second demonstration, and the query execution technology that we added to make that possible in a 6.0 release sort of outstripped the capabilities of our query optimizer in 6.0 a little bit, and so we recalibrated the query optimizer's costing capability in 6.5 to make sure that it picks the best query execution plan that makes use of that new technology that we added in 6.0. We use the TPCH benchmark internally as a performance tracking workload when we test our system. And on TPCH, we got a 2.2 times speed up between MemSQL 6.0 and 6.5 without any application changes at all. And, and I've been in the industry for a long time, and with the exception of introducing column store to a system that didn't have it before, nothing has ever come to experience in a single release cycle to 2.2 times speed up. I've never seen that. The best I've ever seen was a 30% speed up from release to release, except for going from row store to column store. So this is just quite a phenomenal improvement from release to release. The TPCH tracking workload that I mentioned, this is sort of an illustration of the performance gains from MemSQL 6.0 to MemSQL 6.5. The red bars are the time for 6.5 and the blue bars are for 6.0. As you can see how much shorter the bars are for 6.5, sort of across the board. And we've also measured our performance for 6.5 for what's known as the TPC DS workload, which is a modern data warehouse benchmark that not too many people have published official results like this benchmark and is using it internally to track their performance. So we compared ourselves on 6.5 to an industry competitor that has a data warehouse DBMS that has scale out and column store, so it's a very credible competitor. And on the same exact amount of hardware, and MemSQL is faster on 75% of the queries in TPCS compared to, but you know, that's a pretty impressive result because MemSQL is not a data warehouse database system that can handle transactional and analytical workloads. So we're going up against a purpose-built data warehouse DBMS and just blowing it away. We also have extended the capabilities of MemSQL to support full text search to allow us to get insights into data in different and new ways while still capitalizing on the performance and scalability and SQL capability in MemSQL. So you can query data with full text search in MemSQL through SQL, and you can combine regular SQL predicates and joins with full text predicates. So the capability in 6.5 for full text is powered by Lucene. So we basically took a snapshot of the Lucene C++ implementation and brought that into MemSQL. It's an open source system, and we've built that capability into MemSQL and extended our query processing and data definition to be able to use full text search. So it's really fast and efficient. It's fully distributed and fully parallel in execution. So I wanted to do a quick demo of full text search so you can see it in action. So I created a database called Books, and you can see you can create tables that have full text index clause. So that says create a full text index on the title and the body from this table. So let's create the table. I'm just going to insert 3 different books just to show you the functionality. Now, the way it works is it's sort of asynchronous, so it updates the indexes in the background. So it doesn't update the full text index at the time you insert the record, but it does it shortly after. But just to make sure everything's indexed, I'm going to run this command. This is the indexes out to disk so that they're there and ready. And here's a real simple full text query that just wants to find everything that has the word Fox in the title or the body. So you can see that those two documents contain the word Fox right there and there. And let's look at a query that combines a full text predicate, which is matched against the keyword Fox, with a regular relational predicate, which is publish year equals 2014. So you can see that only one of the records above is in 2014, so that we got a 1. So now let's move on to show how you can get a relevance score for full text search. So this query does a match against the keyword Fox, but it also retrieves a relevance score using, taking that match against Fox, as the relevance and outputting it. So you can see that document 2 has the highest relevance. You can sort of see why, because document 2 is shorter, a lot shorter than document 1. So we have relevance ranking that's derived from Lucene technology that understands the relative frequency of different words and the lengths of documents, and that's how we can do a relevance ranking. And finally, you can see you can even use that relevance ranking in the where clause of a query. So down there in the where clause, I've said, I want to retrieve everything where the match against Fox is greater than 0.12. So I only get that document number 2, which has a high enough relevance ranking to meet that condition. So that's a quick overview of our full text search capability. I really just demonstrated the functionality today and talked about what it can do, but what it's good at is if you have a really large and fast-growing collection of full text documents and you want to be able to do a retrieval of documents that match conditions that are full text search conditions against that document collection, it's terrific for that. So for example, if you're ingesting, hundreds of millions of tweets or emails per day and you wanted to be able to search against those with full text search, MemSQL would be ideal for that kind of application. I mentioned earlier that we've done a lot of work in this release, and one of our themes is improved enterprise resource governor, a workload manager, a system event tracking capability. So there's basically an event table that keeps track of all important events in your MemSQL cluster so that you can troubleshoot more easily. We've also introduced a backup history tracking capability, so you have a full record of all the backups that you've done. And we've introduced some very robust cluster-wide user and grant support. So as you grant permissions and add users, everything is atomic and robust across the entire cluster. So MemSQL allows you to deliver very high performance at very high concurrency. That's one of our strengths. And so we now allow you to do this with automated workload optimization that works in 2 different ways. One is with a configurable resource governor. The resource governor is a feature that you need to configure and change your application slightly in order to take advantage of. And what you do with resource governors, you can define resource pools, you can allocate resources to pools, assign connections to specific pools, and those connections that are constrained to only be able to use the resources that are available in that pool. And this allows you to prevent low priority work from overwhelming the system, for example. You can add low priority work to a pool that has less resources so that high priority work can be placed in a different pool with more resources to make sure that it can finish in a prompt way. In addition, we have an automated workload management capability that or any user intervention in order to use. It's fully automatic. And what it does is it looks at your queries as they come in, and it estimates how much memory they're going to take. And if they're very large, if there's not enough memory to run the query effectively, it will queue the query until some other large queries have finished and then allow that query to proceed. So it's based on the concept of queues for different size queries, small, medium, and large queries. And it throttles the number of large and medium queries to make sure that the system is not overwhelmed when there's a heavy load. And this can dramatically reduce certain types of errors that used to occur in previous releases with queries running out of memory and having to be restarted by the app. We also added the capability to build data pipelines into MemSQL with stored procedures to do data transformation. This is a really neat new capability that allows you to use the power of stored procedures, which were new in MemSQL 6.0 last fall, and use those stored procedures to clean up and transform data as you're loading it from a pipeline. And a lot of database developers love stored procedures because they're a great language to implement database application logic that's logic that's very close to the data and has to do a lot of data manipulation. And so ETL style logic can be done with stored procedures with this new feature, so you don't have to do it with external client software. So this can simplify your application environment and also improve performance. And we support pipelines from the Linux file system, Kafka, S3, Azure Blob Store, and HDFS. So the idea is you can have a folder, say, in S3 that contains a bunch of files and start a pipeline to read from that folder. It'll read the files and load data into MemSQL directly, and as new files are dropped into that folder, we recognize them automatically and grab them and load them. And that loading process can now include ETL transforms with stored procedures. Another thing that I really love about MemSQL is its elastic scalability and how that enables highly scalable multi-tenant cloud applications. So we have customers that are able to scale from 1 to thousands of tenants on a single MemSQL cluster. And they absolutely love this capability because it just makes their application development so much simpler. In the past, they've had to create databases on separate single standalone servers for different users, and then they had to manage their own sort of distribution of different databases for different customers onto the servers, and their largest customers could not fit on a single server, so they had to implement complicated logic that sharded the data in the application across multiple conventional database servers that didn't scale out. With MemSQL, you don't have to do that. You can just create one cluster, put all your, create a different database for each of your tenants that scales out across all the nodes in your MemSQL cluster, and every customer from the largest to the smallest is handled in exactly the same way. So the situation where you have some customers who are extremely large and some that are very small and have a distribution that's known as the zip distribution, where you've got a few big items and a long tail, that's super common, and with the scalable multi-tenant capability of MemSQL, it makes the application developer's life so much simpler. They can handle every customer from the largest to the smallest in the same way, scaled out. And by the way, they can scale out on-premises or in the cloud. So MemSQL is fully cloud-enabled. You can run MemSQL anywhere. You can run it in the public cloud, you can run it in the private cloud, or you can run it in your on-premises data center. And we're continually adding more cloud capability. We've recently added the ability to do backup and restore from Amazon S3. And also, we've added capability to do highly scalable pipelines from S3 that are very high performance. So to recap MemSQL 6.5, we've tremendously improved our query execution time. So we provide fast and latency-free query processing. Not only is it fast, not only do the queries run fast, they start fast. So if when you can get instantaneous response time from MemSQL. Queries run from the time you submit them from the client app till the time the data is returned from the server. They can run in milliseconds. So there's not a high per query overhead on MemSQL. So and in addition, even if they're very large, they can process the data really fast. That's what we mean by both fast and latency-free. We've improved concurrency with automated workload management and the resource governor capability. Our real-time data pipelines capability with stored procedures now lets you transform data from a pipeline inside the database with a very convenient and powerful programming language inside our stored procedures. We've added capability for full text search, which lets you mix full text predicates and scoring in with your regular SQL logic, and it's just tremendous for very high scale requirements for full text, where, for example, searching high volume text documents like tweets or other social media or emails. We also easily scale multi-tenant cloud applications. Again, with that zip distribution concept, the largest and the smallest tenants can all live in different databases on one cluster, simplifying the application developer's life tremendously because they don't have to worry about sharding in the application layer, which tremendously complicates the implementation of the app. So what I'd like to ask you to do next is to try MemSQL 6.5 or get a personalized demo. You can try it yourself for free. You can go to that URL there, go.memsql.com/enterprise-trial-6.5. If you'd like a personalized demo, you can go to go.memsql.com, demo request 6.5, as shown there. And so please try MemSQL today. So with that, I'm going to kick it back to Jennifer, and we'll take some questions.
Great, thank you so much, Eric. So just a reminder, you may submit any questions you have through the Q&A function located in the lower right side of your console. So let's go ahead and get started. So we've got a handful of questions that have come in. So first question is, how soon can I expect job scheduler from MemSQL, something like a SQL agent job that's available in SQL Server?
Yeah, it's a good question. We've mapped out our roadmap for about the next 6 months. I don't see us providing that in the next 6 months, but we're actively improving our system administration and management capability, workload management capabilities. That's something that we have considered, and so I would say, it may happen in like the second half of 2019, but we can't commit to that yet.
Thanks, Eric. We've got another question. This person would like to know why MemSQL SQL language is not as robust as SQL Server T-SQL.
So I would challenge is a full-featured SQL implementation. It's a very broad SQL coverage. We have a powerful query optimizer and query execution system. So I feel like we have a high quality and robust implementation. Every system is different, but MemSQL has a lot to offer. It's very robust, very high performance.
Thanks, Eric. So I have a question. So instead of command line, why did your demo not use MemSQL Studio?
I was just focusing on the full text search capability, so I didn't want to, have any sort of, add any complexity to that demo. But MemSQL Studio it's not officially part of 6.5, but it's now available to try, and it's in beta, and it is a full-featured web-based console user interface in order to try MemSQL, from the web and browse your schema. And so that's an important improve system manageability and the developer experience. But today I didn't demonstrate it, just I want to keep things simple.
Great. And again, folks, if you guys do want a demo that looks specifically at that, we are happy to, follow up and we do a personalized demo after the call. So next question, what is the difference between MemSQL full text search and AWS Elasticsearch?
You want to handle that
Sure.
one?
Well, AWS Elasticsearch is a dedicated service for just doing full text, whereas we support full text search as a feature within the MemSQL relational database. So with MemSQL, you can have your structured data and your full text data all mixed into one application. You can actually mix structured and full text search queries in a single query. Whereas with Elastic, you just get the Elastic model of full text search, and that's it.
Thanks, Rick, for answering that one. Another question we have is, do you support pipelines for Oracle, MySQL, etc.?
So pipelines is geared towards queue-based data, or we treat files as essentially a list of, so in a similar way. So it's basically for file systems and queue-based data. We're working on a feature that'll be in an upcoming release to allow you to pull data from relational database systems. So look for that coming soon.
Sorry, the next question is, does MemSQL do the same thing as Spark?
So Spark is think of Spark as more of a programmatic layer where you can build functionality in a programming language. It's not a storage layer. So MemSQL is a database, which means it does storage and query processing, whereas Spark just essentially does processing. So they're not really the same, and in fact, many people use Spark and MemSQL together, and we have a Spark connector that can do bidirectional movement of data between Spark and MemSQL. That's a first-class feature of MemSQL, and often people find that using them together, they complement each other, and they can do powerful things with it.
Thanks, Rick. Next question we have is, what is the difference between resource governance and workload management?
Resource governance is a feature that you need to use. It's not automatic. It allows you to create pools of resources and assign users connections to different pools, and that constrains the amount of resources available to queries submitted by that user that's in that particular pool. Workload management, on the other hand, is a fully automatic feature, which queues queries based on the amount of memory resources they're going to need to execute, depending on how busy the system is. And so it's like an automatic kind of feedback control system that knows how much memory is being used in the system and will sort of throttle the queries that are running on the system to keep everything running smoothly under high concurrency. So, short answer is resource governor is a system you have to configure, while workload management is fully automatic.
Thanks, Eric, for answering that one. So the next question is, how is the query cache being handled in the latest version of MemSQL?
The query cache, sounds like the question is about the query plan cache. So MemSQL, like some other database products, has a query execution plan cache. So when you run a query, the query gets parsed into some sort of template, and then optimized, and the optimized plan is stored in the plan cache. The next time the same query comes in, perhaps with different literal values plugged into it in the same places they were before, is sort of turned into a template, and that template is used to look up in the query plan cache to find the execution plan and then run it. So yes, we do have a query execution plan cache and a high performance way to templatize a new query that's come in to see if there's a matching plan in the cache and use that plan in the cache. And we have an in-memory component of the plan cache as well as a disk-based component of the plan cache. So, that where plans can persist for up to a couple weeks, even across system restarts, to avoid the overhead of compilation for a query that has been seen before.
Thank you, Eric. Another question from the audience. Does MemSQL have any integrations with IoT software platforms?
So MemSQL is wire protocol compatible with MySQL. So we have a quite large ecosystem of technologies that we interact with. I mean, you'd have to give me some examples of the IoT platforms specifically that you're talking about to know whether they'd work. But we find that most of the platforms, since most of them have some sort of MySQL connection, will work with MemSQL.
Thanks, Rick. Yeah, and if you want to clarify that question, feel free to resubmit in the Q&A function. Next question is, when and if MemSQL will allow for the repartitioning of the database as the cluster expands?
That's a feature we're working on for an upcoming release.
Okay, let's move on to the next question. We've got a few minutes left. So how hard would it be to configure an S3 pipeline that reads Parquet files from an S3 bucket?
It's quite easy. In fact, one of our sales engineers built that. It took him less than an hour. You just have to create a transform that transforms the Parquet into CSV. In the future, we'll have a native way to do that that comes out of the box. But if you want to follow up, we can give you the sample code that does the transform. It's not very many lines of code.
Okay, thank you, Rick. Next question is MemSQL like Hadoop? Can it handle structured and unstructured data?
Absolutely. So MemSQL is very, very good at structured data. That's sort of the core. We also support JSON data as a native type. So you can create a JSON column, stick your JSON in it, and then if you have particular properties that you want to index, you can project them out as columns and then index them. So you kind of get the best of both worlds there.
Yeah, and another thing I can add is that we do support user-defined aggregate functions. So you can do something that's a little bit akin to MapReduce with a user-defined aggregate function.
Yeah, we also support spatial, and then as we've talked about, full text search. So whatever your type of data, we allow you to store it and efficiently get access to it in MemSQL.
Awesome. Let's do one more question. So similar to SQL Server, will there be any chance to allow users to change their password once DBA has created a database user?
You can change your password today. So we actually support multiple forms of authentication. There's a username password model where you can set your password and change it if you have the permissions. We also support allowing you to do single sign-on using an existing identity outside MemSQL. So that way there's no password to manage within MemSQL. It's all maintained. And then we also support PAM integration, so you can use Linux identities as well.
Thanks, Rick. Last question. Does MemSQL have any ETL tools that provide connectors to MemSQL?
So as I mentioned, because we're MySQL compatible, we work with most of the ETL tools out there. We are working on building some native tools you can get most of the tools to work today, as long as they have a MySQL connector.
Great. Thank you guys again. So thank you, Eric and Rick, and thank you everybody for attending. Unfortunately, that is all the time we have for questions today. So for those of you guys with questions we haven't addressed, we'll be sure to follow up with you after today's presentation. So I just want to thank Eric and Rick and everybody for attending. Just a reminder, we will be sending you a follow-up email with a link to today's recording and slides. If you have any questions in the future, please send us an email to team@memsql.com. So we invite you to get started with MemSQL 6.5. You can give us a try for free by filling out the form at go.memsql.com/enterprise-trial-6.5, or go ahead and request a personalized demo, just a one-on-one demo with one of our database experts at go.memsql.com/demo-request-6.5, and you can see on your screen the URLs, and we'll add them in our follow-up. So again, thank you guys for attending, and have a great remainder of your day. Bye.